In this tutorial, we will continue exploring the different ways to define and manage functions in VOLTRA. We will take a closer look at the default template functions, learn how to link climatic data in EPW and TMY formats, and finally understand how to generate user-defined functions. As in the previous tutorial, we will continue working with the same exercise. The corresponding exercise files can be downloaded from the link provided in the video description. To begin, click on the Functions icon in the top toolbar. In the Functions window, locate function T01. Previously, the internal temperature was defined using a sine curve. Double-click on the function type to modify it. A list of available template functions appears. You will see 5 standard options: Step 0, Step 1, Step 2, Sine, and Positive Sine. For this example, select Step 0. And define the parameters as shown here. The description of each abbreviation is displayed at the lower left of the screen, and a graphical preview allows you to visualize the selected function before confirming your choice. Next, locate function T02, where the external temperature was also previously defined using a sine curve. Double-click on its type and select EPW from the list, as we will now link this function to a weather data file. EPW files can be downloaded from a variety of online sources. You can refer to the VOLTRA manual for the requirements of the EPW file. In this example, we use a EPW file for Brussels. Download the EPW file and save it in the same directory as your VOLTRA project file. Back in the Functions window, click on the filename field and browse to select the downloaded EPW file. Once linked, the annual weather data for 365 days becomes available. You can zoom into the graph by drawing a rectangular selection with the left mouse button, or by using the scroll wheel to zoom in and out. Suppose we want to run the analysis using outdoor temperature data for 2 winter days starting from February 1st, open the Calculation Parameters window. To determine the correct start date, click on the information icon. A reference table shows the corresponding day numbers for each month. February 1st corresponds to day 32. Close the guidance window and enter 32 as the start day. If we begin the calculation at 4 p.m., enter 16 as the starting hour. Set the time step to 1 hour. The startup duration to 1 day. And the total calculation duration to 2 days. Return to the Functions window. The internal temperature remains defined by the Step 0 function, fluctuating between 16 and 20 degrees. The outdoor temperature is now linked to the EPW file, and the 2-day profile beginning on February 1st is selected from the annual dataset. These temperature functions are connected to the boundary conditions via references T01 and T02 in the Colors window. If you wish to visualize only the selected 2-day period, open the Functions menu and select X Scale. By default, the display is set to Function Scope. Change this to Calculation Time. The graph will now update to show only the time range defined in the calculation parameters. You will see temperatures from -24 hours to 0 hours, representing the 1-day startup period on January 31st, followed by the 48-hour calculation period from February 1st to February 3rd. To display the full annual profile again, return to X Scale and select Function Scope. Before running the analysis, ensure that Save Frequency is activated in the Calculation menu. This option allows the results to be visualized later in the graphic output. Start the calculation. You will notice that VOLTRA first performs the startup calculation and then proceeds with the 2-day simulation period. Upon completion, click on Graphic Output. We will now adjust the graphical scale by clicking on Settings, Temperature Range, and setting the minimum to 0 and the maximum to 25. Click on the next time step to visualize the results for the next analysis time steps. You now can close the graphical output and open the Functions window. In addition to EPW files, VOLTRA can also link TMY3 files, which are annual weather datasets provided in CSV format. Weather data files can serve not only as temperature sources but also as inputs for global horizontal radiation and diffuse horizontal radiation. These applications will be demonstrated in the next tutorial when we introduce the solar processor in VOLTRA. Next, we will learn to input customized data for a function using an external file. All the parameters shown in the functions window can be through a user-defined function. We will create a new function using a customized data curve to define thermal conductivity as a function of temperature. Each external function file uses a specific extension depending on the type of parameter. Time-dependent, temperature-dependent, and angle-dependent functions each have their own corresponding extensions. Detailed information can be found in the VOLTRA manual. You can access it through the Help menu by selecting Manual and navigating to Chapter B.12, which explains the functions window in detail. For temperature-dependent material conductivity, the required file extension is .fla. To create a new function, click Insert after and assign the reference L01. In the Colors window, assign L01 to the conductivity property of the concrete material. The function is now linked to the material's conductivity. A set of default temperature-dependent material properties are available from the Material Library and Editor in the Physibel toolbox. Double-click on the function type and select File from the list. Browse and select the external .fla file containing the conductivity data. You can open this file in a text editor such as Notepad to inspect or modify the data. The left column contains temperature values, and the right column lists the corresponding thermal conductivity values. Further guidance on creating or editing external function files can be found in Chapter H of the VOLTRA manual. Additionally, custom climatic data files can be created as an alternative to EPW or TMY files. Instructions for this process are available in the Physibel knowledge base under the title, F3, Preparing Climatologic Data in Physibel Software Format. Functions can also be used in the Controls window, where they can switch based on sensor temperatures and heating or cooling purposes during the simulation. This topic will be covered in a future tutorial. To summarize this tutorial, the indoor temperature is defined using the built-in Step 0 function. The outdoor temperature is linked directly to an EPW weather data file. And the concrete conductivity is defined as a temperature-dependent function using an external .fla file. Run the analysis again. After completion, open the graphic output to examine the temperature profiles at each time step. In the text output window, open the report output to review the numerical results corresponding to each report definition. As demonstrated in the previous tutorial, report definitions can be created or modified via the Edit menu under Report Definition. Thank you for watching, see you in the next tutorial.